I had just the wrong button. I didn't want to record it on my computer. Good morning, everybody. It's our great pleasure to host now the second AI discussion, this time about what semiconductor companies' opinion is about the AI. And I would like to introduce, without any further ado, our wonderful host, Deborah Magid. She is the resident CVC EIR at Pitch Global at this point in time. Deborah and I have a long history,
very long
history in the innovation system. And before Deborah, I had personally a very long history with IBM. Never worked for the company, but was very instrumental in many areas coming to Germany already in the early days. You remember IBM PC, when that came out, we evangelized IBM mainframe to PC technologies. We were early on in many developments, and Deborah was leading often the way of multi-million-dollar investment or be involved in the AI space. And it's quite natural for Deborah to be leading now our panels in the AI space. Deborah, the floor is yours.
Thank you so much. So I don't know if everyone on the phone knows this, but my degree is in cognitive psychology. And so I was studying AI so many years ago. I don't want to tell you how long it was, but that's what my degree is in. And so we used to fund, I was at AT&T for my first corporate job. We used to fund AI research at MIT when they were just studying neural networks. And so I've been tracking this for many, many years. And the acceleration through generative AI since November, when ChatGPT came out, and then other corporations started, well, they had already started looking at this way of dealing with information and people and the answers to questions. It's really been accelerated lately. So we're doing this series of small events online and bigger events in person over the next several months. Actually, we've got some things planned out into May with a security theme at RSA. We're going to talk about agriculture and food tech in October. We're going to talk about clean tech in November, deep tech in December, and healthcare in January. So we've got quite a lineup. I want you all to know that we're going to do an in-person event at Perkins Coie, the law firm on Page Mill Road in Palo Alto, on September 21st. We may have some of our delightful people come back for that, and I have a lineup of new people to invite. So that will be from 2 to 6 in the afternoon on the 21st. And I hope to see a lot of you there, at least if you're on the West Coast or traveling. So we'll get started. We're going to have a really great opening remarks from a new friend of ours. So Axel, do you want to introduce Gerard?
Why don't you do this, right?
Okay, I will do that.
because you wrote me, so I didn't prepare. You wrote me that today would be all the introductions on your shoulders. So,
so Gerard Cunningham is a senior partner at McKinsey, and he's been tracking AI as well, and just really been deep into that in the last year or two, and would like to talk to us about what he's been seeing and what he's been hearing in that regard. So Gerard, over to you. And I hope he signed in, because I sent him the link for this call very late. He didn't send it. Oh, there we are. Yay! Thank you. I'm glad you got it.
Oh, that's okay. How are you, Deborah? And
good to see you again.
Good to see everybody. Let me just see if I can share my screen here. So Deborah asked me to share a few thoughts and slides on whether generative AI is ready for the enterprise. Well, why don't we run through these slides? I'm going to bang through these slides very fast. So there's a bunch of them, but we're going to be very quick on each one. And let me just start by saying I am a partner of McKinsey. Gerard Cunningham joined the firm 4 years ago after 25 years in the software business in a few different areas. And I joined to reinvent myself all around climate. But having built AI in the past and seeing the advances of the last year, the pull of AI is pulling me back. And so I am part of our Gen AI Tech Council and creating, beyond creating our climate tech practice, creating now Climate Plus AI, an internal initiative around how these two things come together. We don't need to go for my background, but as I say, I spent a lot of time AI in a bunch of different roles on the corporate side, and I've lived through a bunch of revolutions. And welcome to the next revolution. So some of us have lived through the PC, internet, mobile cloud revolution, where we've got a new compute platform in terms of hardware and software. And what we have right now is two things coming together. The generative AI set of software sitting on top of our accelerated computing environment. And it's just such an amazing thing and such a delight to be part of another revolution where everything gets reinvented all over again. And we at McKinsey have done a whole bunch of work researching what we think the impact of generative AI will be. We estimate that 60 or 70% of people's time could possibly be automated by AI, allowing us to have superpowers as we get augmented. And as that kind of activity happens, we think that there's going to be an amazing impact on productivity around the world. $4.4 trillion of increased GDP coming from increased productivity across key functions. And I just pick on one of them, the sales and marketing. We've obviously seen a lot of examples related to copy, videos, images. As those things get automated or accelerated, augmented with generative AI, huge impact there. We've all seen it with software engineering, etc. But huge productivity opportunities. And when we look at it, this is not just in one or two sectors. This is the entire economy. Every single sector we think is going to be impacted by generative AI over the coming years as it gets rolled out and adopted, as we solve the problems and make it part of our everyday working processes. And over the last 20 years, we've actually seen a decline in productivity. In the first decade of the century, we went from with 2.5% growth annually, GDP globally. It declined over the next decade. And we're predicting that over the next 20 years, we will see an upswing. 60% higher productivity growth. That is quite remarkable if this comes through. So really quite an amazing time we think we're going to go into. And of course, one of the big questions is why now? There's a lot of talk about the software itself. And we've been working on AI a long time. When I was at school, which is now 35, 40 years ago, we were talking about AI and how it was going to do what it's doing today. We didn't know how it would happen. And we've seen the iterations of the software, and it's got better and better. And we've got new algorithms that were only dreamed of 20 years ago, 30 years ago, 50 years ago. But one of the things that's happened that's really enabled generative AI today is accelerated computing, where we have now leapt from the age of CPU and the declining improvement due to Moore's law into this world of specialized chips, where we've got the CPUs and DPUs and the integrated solid state memory, so that companies like NVIDIA are seeing enormous improvements. I don't think we're going to see this improvement of 1 million times in 10 years over the next 10 years and the following 10 years, but we are going to now see continued enormous improvement in the hardware itself. And so these two things together, when we really think about how the software and hardware come together for this age of AI, we are going to end up with a new tech stack. Our data centers are going to look different. It doesn't mean we're going to rip out the old data centers tomorrow and replace them with the new ones. But as Microsoft, for example, has said, they expect to have 3 times the number of existing data centers in the world, only for Microsoft. So as we add 10 or 100 times the number of data centers, we will see that this new tech stack, or something approximating this, gets rolled out. And as it gets rolled out, this new hardware, new software is going to change the world around us. Now, look, I talked a lot about productivity, which is all about making old processes better. So we can do more, we can do it faster, we can do it cheaper. But those of us who've lived through previous platform shifts, we also know that this is also a great time of innovation. And suddenly new business ideas are enabled, or old ideas that we couldn't execute before are now enabled. So we're going to see, in addition to the productivity improvements on the old activities, we're going to see new products, new industries emerging. And we think this is going to be an incredibly exciting time. Now, I mentioned earlier on, I joined McKinsey after many years in software and started leaning into climate. So of course, one of the first things I start thinking about when we think about new products, new industries, I can't help but think about AI plus climate. So to make that just slightly more real, a couple of ideas that we've been talking to folks about and we're quite excited about in terms of being able to impact our climate immediately. Our grids right now, as we add more clean power that is now more intermittent, as we add batteries, as we start having more challenges with some of the peaker plants. And I'm in the UK today, and I've just been talking to some folks about the fact that we've got more diesel peaker plants than ever before, sitting in farmers' fields, ready to get switched on if the grid calls on them to be switched on. So we've got this legacy system of the grid. We've got this new set of technologies being rolled out that is completely different. We've got microgrids being plugged in. We now have a very, very complicated grid. And if we could manage this better using AI, create a real-time adaptive grid management platform that is based on predictions of what the demand will be, and then adapting the grid as needed, we would actually be able to save an enormous amount of power and therefore actually have to build less new plants. A different example is data center management. We've now seen that we can actually, it's really hard for companies who do air conditioning of data centers or frankly, any complex manufacturing environment where they care about the environment being temperature controlled. It's actually really tough for Johnson Controls to put in exactly the right air conditioning equipment that can deal with the changes during the day, during the week, the year, and over longer periods of time. And software has found it we found it very difficult to deal with software as well. What we're seeing now is some of the early experiments by using generative AI, again, to predict the environmental changes based on previous patterns. We can now start controlling environments in a much, much better way, again, saving energy and saving a lot of cost as well. Completely different example. I live in California, and over the last couple of months, 2 of the largest North American insurance companies have stopped issuing new home policies in California because they are very worried about the risk related to fire. However, one of the things we've discovered is their models are backward-looking and neighborhood level. They are not based on forward-looking house-by-house estimations of risk, estimation, and therefore calculations of premium. And we think there's an opportunity here for some new insurance companies to come up, new methodologies. So here's just a few examples. We could go on and on. The new innovation that is now possible in this age of AI is very, very exciting and will really change a whole bunch of industries. and look, it's not just climate. We think it's every type of industry. Now, the age of AI, there's a lot of talk about risks that I don't want to get into related to the AI apocalypse or the various lies or hallucinations they make. But one of the interesting things that is a threat to corporations is that the AI natives are on the attack and taking top talent, generating high valuations. One of the things that may not be obvious to us all is actually it's the current high-tech companies that are also massively under attack. The 7 people who wrote the Transformer paper, who all worked at Google just a few years ago, have now all left, are all in different startups, all of which have raised hundreds of millions of dollars. Google is under attack in this age of AI. They are going to have a talent drain, or having a talent drain. If Google is threatened by the age of AI, how are other corporations going to compete in this world where the talent is so hard to get? And it's a real conundrum, except the corporates have got amazing strengths. And we often forget in Silicon Valley, where we're so excited about startups and how we are going to disrupt and change the world, that corporations exist and continue to exist through these transitions. Many of them, if they're very, very smart about using their key assets like data and brand and content, their customers, the distribution network, and the huge amount of capital that they have. And so this can, although it is a challenge, the smarter corporations actually can deal with this threat. And corporations have got huge strategic choices. Many corporations have got assets to leverage, and they have high opportunity that they could take. And there are some that are more threatened than others. For example, maybe some of you saw Chegg lost the education company that helps students pass exams. They lost 50% of their market cap when the CEO reported earnings and could not provide guidance for the rest of the year because the use of Gen AI was damaging their business so much. And so that's a company that's dramatically under threat. But with the opportunity and threat matrix, I mean, sure, there are companies who can just wait. And maybe they are the laggards in their existing industry. Maybe their industry doesn't use technology very much. They can wait. And there are others like, as I said, the Cheggs of the world who really have to move fast to reprioritize and protect their core. There are others who've got incredible assets who should be placing bets right now on how to accelerate their growth. Is it whether it's placing bets internally or through their corporate VC, they should be placing bets so that they can quickly identify opportunities so that at the right time they can deploy them through and across their enormous assets and create massive enterprise value. And then, of course, there's those companies who are probably more digital, who have incredible opportunity and have incredible threat. And those companies, they should be going all in, probably doing more experimentation inside as well as through their CVC, through partnerships, etc. And this set of corporate strategic choices is a tough conversation in a world where you are making a compute transition into a new age of compute. But the best way to predict the future is to create it. And I'm aware that I'm talking to folks who are in CVC. And so I think it is up to you guys to really lead the way here and help your corporations address those few things. Because you're not, and now we did some research on what do CEOs and actually people who run CVCs, what is the purpose of the CVC in general? And you'll notice that fund returns is not the number one. And I'm sure that's no surprise to those of you working in CVC. Yes, fund returns are desired. Yes, pay for yourselves at the very least. Please bring back extra capital. But in addition, the number one was market insight, opportunities to help drive revenue, and of course, building capabilities, ecosystem participation, so building partnerships and other competitive advantages. So corporations are looking for you to help them in this kind of period. And of course, we do have this kind of holy grail of, if you can bring in the strength of your corporations with the energy of a startup, then maybe you can make magic happen within your parent corporations. So just quickly in closing, it's the age of AI, Gen AI plus accelerated compute gives us productivity and innovation. Our enterprises, is AI ready for enterprises? Absolutely. This is really, enterprises need to be ready for Gen AI. And this is a new credible threat, but you've got incredible assets. There's an incredible opportunity as well. And you guys are the ones that we think have the opportunity to create the future here. So, thus ends the prepared remarks. The best defense, of course, is this great offense. That is the overall message here. I'm happy to have any questions, or if Deborah and the time is required, we should go on into the panel, whatever you all would prefer.
That was a great lead-in, because we now have a panel of CVCs, and I think they'll agree with you. Any quick questions from the people on the phone or the video? We're going to have a Q&A for the panel as well, and you can also put questions in the chat if you have any. So we have a wonderful panel of CVCs, and let me tell you who they are. Robert Lee is from Micron, John Wei is from Applied Materials, and Eva Liu is from Lam Research and Lam Capital. So they're really in a position to say how they represent their firms, what their firms care about, and how things are being transformed by Gen AI. So the question before the panel is, how is generative AI transforming the semiconductor industry from the point of view of the CVCs who represent these corporations? So what I'd like to do now is have the panel each say a few words about themselves and their firm. Robert, can you go first and say something about yourself and Micron?
Sure. Hi, this is Robert Lee. I manage the VC fund at Micron Ventures. We have Fund 1 that was actually focused primarily on AI. And then we have Fund 2 that was launched in 2022. That's broader in deep tech innovations, ranging from semiconductors, of course, but storage solutions, memory processing, mobility, Industry 4.0, Gen AI, of course, and then sustainability. So those are sort of a broader categories that we're focusing on. And obviously with Fund 1, we have several companies in our portfolio that is actually making a significant impact to our organization. So I'll talk a little bit more about that.
Can you say something about yourself and your background and how you ended
up?
Oh,
yeah. Okay. Well, so I actually started my career actually at KLA. So I was also semi equipment experience. So I also after doing operations there, I managed their M&A group and then launched their corporate VC group there. So I've done other things in clean tech space as a startup entrepreneur. Did strategy consulting within startup ecosystems, working with VCs and their portfolio companies. And then most recently, I was in investment banking, mostly in sell side. So I've done both sell side and buy side investment banking activity. And then now I'm back to semiconductor.
That's quite a career. You're going to enjoy Micron, I'm sure.
Yeah, I love it. Thank you.
So John, can you say something about yourself and Applied Materials?
Sure. Hello, everyone. So this is John Wei. I am investment director at Applied Ventures. My background is in chemical engineering. I joined Applied Ventures about 3 years ago. Before that, I was doing corporate venture investment mostly for a petrochemical company. So mostly investing in advanced materials, clean tech, kind of and energy kind of space. And at Applied, Applied Materials being one of the largest, perhaps the largest semiconductor equipment maker. At the ventures team, our focus is really looking at innovations up and down the semiconductor value chain, all the way from materials to equipment, processes, tools, and all the way down to new device, new chip architectures, and anything related to compute hardware. Outside of the semiconductor core, obviously, we also look at the general deep tech space, go anything from AI, ML, software, data security, even life science, a number of different spaces that we look at. So that's kind of our investment focus. And Gen AI obviously is a hot topic, and we've been kind of looking at this from different angles as well. Happy to share with the group a little bit later. I wanted to maybe point out for those who are deep in the weeds of AI chips or fan of Jensen Huang, my background is actually Jensen Huang's kitchen. He literally, when he was introducing the A100 chip, he literally pulled a chip from the oven behind me. So I thought that was fitting for today's call.
Oh, that's fun.
Thank you.
Thanks. Eva, do you want to say something about yourself and Lam Capital?
Yeah, sure. Hi, everyone. My name's Eva. I've been working with Lam Capital for 4 years. Lam Capital is a venture investment group of Lam Research, and we're the leading provider of the wafer fabrication equipment. So we invest in early stage companies in the semiconductor space, spanning from like AI chips to industrial 4.0 and sustainability. So besides funding, we also provide internal resources and partnership to accelerate and enable the growth of the startups. My personal background is in finance, and previously I worked in a tech startup. And thanks for having me in this panel.
You're most welcome. So now we're going to get started, and we'll start with Robert and talk about chip development and design and production. So, you know, by the way, I should say something about myself. I'm a softer gal, but being in corporate strategy and being in the venture group at IBM, in our CVC, I did support all of IBM's businesses. So that included consulting. It includes the hardware business, which has a good semiconductor business as part of it, which Sanjay will talk about right after the panel. And so I've been supporting the semiconductor and hardware group for the last 3 years or so. So I'm not as deep as you guys, but I'm not a novice either. So anyway, so you know, I do know that analysts have said that the use of Gen AI and just AI and ML in general in the chip design processes has a lot of benefits. It reduces costs, it reduces the resources required and time. It can increase throughput and also can help with the quality of the outputs because you can do visual inspection of the wafers and so forth. Now, those benefits have been going on for some time. So what I wanted to ask Robert and then John is Gen AI, generative AI, specifically showing even greater benefit in the past few months when we think about designing chips and developing them and getting them through the processes?
Sure.
Let me go first.
Yeah, sure. Let me talk briefly about that. So obviously there are just a lot of potential and excitement here. Just looking at our entire process of chip design and development, but it really depends on what stage in sort of the design process you're considering and sort of, you know, trying to measure the actual value creation that you're going to do. So we're looking very carefully about each one of those processes and determine what is the best kind of opportunity for automation or sort of generative component of that work. So we've been doing that, and most recently with Gen AI, that has actually kind of accelerated some of those programs. Let me give you a couple of examples sort of in our design and development processes. One is sort of the materials R&D. Now the timelines there are measured in decades, okay, not years. And the associated costs that is just exploding with, you know, learning how to, you know, really manufacture these increasingly complex semiconductors while you're dealing with all these different variables that you have to take into account, such as clean energy materials, and at the same time try to achieve that target yield level. So it's an extremely complex kind of a formula that we've got to try to optimize. And so we have one of our portfolio company named Multiscale. It's an R&D analytics platform that's specifically designed for materials process discovery. And so how do you define a new manufacturing process and accomplish yield targets while sort of optimizing for cost, energy efficiency, decarbonization, et cetera, other variables that we have to take into consideration. And so these are, again, incredibly complex, multi-dimensional problems where AI really serves two main purposes. One, it really simulates simulates as well as predict how specific materials, structures will respond to various different process settings. And then two, with Gen AI in particular, what we found is that it extends the usability beyond just data science teams to more sort of traditional kind of specialized kind of team players like material scientists. So we're actually using them and launching a new interface powered by Gen AI, where we give non-technologists sort of for them to rapidly explore some new experimentation and with some new materials. So I think that's one of the key values associated with Gen AI. You expand sort of the user base by having that capability. And then the second example that I could think of is sort of in the other end. With as Micron, we developed so many millions of lines of test codes to make sure that our chips function in all the target use cases. So this is obviously a very incredibly labor-intensive, repetitive work that sort of dominate the time for our high-value workers. So we're exploring this space with a few of our startups in our existing portfolio. One of them is Normal Computing, which builds sort of this probabilistic machine learning platform, and it solves a problem around sort of the trust, scalability, model hallucinations, drift, things of that nature of the Gen AI output. So we're really excited about sort of the work that they're doing there. So that gives you another example of Gen AI influence in our chip design processes. We're also talking to several other new startups in this realm with the expectation that we're going to get some significant value out of the interaction with those startups for our operations. I mean, these are a couple of examples, but as we go through our entire processes, we're identifying sort of those ones that are low-hanging fruits first, but we have additional, kind of opportunities that we see. And as a corporate VC, we're always trying to identify those startup engagements where we actually can extract significant value for the company that is actually measurable and quantifiable. Those are the best kind of engagements, rather than just the basic, quote unquote, learning. That's how do you measure that? But
that's right. And that's very exciting. We're going to talk about the startup world, your investments in a few minutes. But since John is looking at the entire value chain, can you comment on this as well? Design and production and so forth, all the way through manufacturing.
Yeah, sure. So, being, I guess, in the semiconductor equipment space, I think first and foremost, we look at Gen AI, we see ourselves, or the entire semiconductor industry, as both sort of enabler as well as beneficiaries of Gen AI capabilities, right? So on the kind of hardware side, the industry has always been excited about pushing the boundaries in terms of performance, power, and cost. Developing better, cheaper, and more efficient hardware. And so if you've seen recent announcement from NVIDIA, they introduced this I think GH200 chip that is specifically for large language model inferencing. A lot of technology, hardware technology goes into that. Emerging memories and advanced packaging technology that put things together. So these are all the things that we in the semiconductor industry have always been sort of excited and interested in. And with Gen AI, it just adds a whole lot of interest, a lot more interest into this space. And also, again, from a infrastructure perspective, not just at the chip level, at the data center level, there's a lot of hardware infrastructure that need to happen. For example, data interconnect, IOs, and etc. We previously invested in a company called EIR Lab. They develop photonic optical IO chiplet that help you to do, I guess, data transfers much more efficiently, much faster. And these are all going to become increasingly important in the world of Gen AI. Think about what Gerard was saying. Even Microsoft is going to triple their number of data centers. On the flip side, in terms of how we utilize AI and Gen AI, I think traditionally we have always been sort of trying to incorporate all sorts of AI tools in our manufacturing processes for predictive maintenance, for anomaly detections, and etc. And there are certain areas I think Gen AI tools could be of use. It could be helpful. I think generally Gen AI would do well when there's a lot of data, and whether it's labeled or unlabeled, and also when context matter, right? When sequence matter and context matter. That's kind of the gist of the whole Gen AI. So in that aspect, we kind of see perhaps some of the computer vision related applications, like wafer inspections and optical image analysis. These are good areas where we could employ sort of Gen AI tool. And I think what Robert mentioned in terms of some of the productivity gains, whether it's code bug detections or just general sort of functional groups productivity gain, that obviously is a no-brainer for our industry as well. And I think there's another sort of smaller area called the synthetic data that is perhaps part of Gen AI that we're working with some companies and looking at techniques to incorporate some of these techniques into, again, the image processing or anywhere when you don't have sufficient raw data to train your model, to effectively develop your AI model. So those are some of the examples of areas that we look at. Maybe one more example is we're working with a startup company at a very early stage. They're developing sort of semiconductor process models, AI models. And what's different, is traditionally all the AI shops, they basically say, give me data, I'm going to build a model for you, and it'd be all good. The problem often is when situation changes, when data changes, you need to retrain, and therefore a lot of sort of hand-holding is needed by these AI shops. This particular company, the idea was to utilize some of the Gen AI techniques to not just learn sort of pattern matching with the traditional sort of AI modeling methodology, but actually train the model to learn the underlying physics. Kind of like, in our sort of a large language model, Gen AI tools are trained to kind of understand context, understand the sentiment. And so in a similar manner, these company become very interesting if they can really do what they are claiming to do in terms of utilizing Gen AI techniques and training models to understand the underlying physics, and then apply that at different kind of domain and different grid sort of a resolution. That makes these tools a lot more interesting and also very efficient when it comes to application. So these are some of the areas that we're exploring and actively talking to startup companies.
Understanding the underlying physics, that's exciting. I didn't know about that. You know, you mentioned that Gen AI helps when there's a lot of data and when context matters. I'm not sure if everyone listening in realizes how many pieces of equipment there are in a manufacturing line. There could be dozens or hundreds. So has Gen AI been helping with predictive maintenance because you have so much stuff to look at and understand?
I have to say at this moment, we're not in applications in that specific area. I think part of it is because the data is actually very, very difficult to get. And, you know, for example, our customer Micron, they will not share their operational data, process data.
Of course.
And there's a lot of this actually brings up the topic of something called privacy computing. You know, how do you share data between different entities and without jeopardizing the data. But for that particular area, like a predictive maintenance, anomaly detection, we're not quite seeing Gen AI playing a role. Perhaps also, like I said, you want to Gen AI will shine when there are a lot of data available and when context is really critical. So perhaps those are the areas like image processing are where I would look for Gen AI applications. Okay,
that totally makes sense. You know, Robert mentioned the materials that are being used in research on materials. And I know that getting the materials to the right place and sourcing them has been a real risk for the whole process during the pandemic, for sure. But the supply chain risk is still very real. Eva, do you want to address that problem?
Yeah, so for the crisis in the supply chain, the semiconductor space was well known, especially after pandemic. I think so for now, the demand from the very end market has softened recently, and the supply chain crisis is kind of, well, largely self-resolved. But yeah, the chip supply situation still has some uncertainty. And nowadays, we know the demand for NVIDIA's GPU still exceeds its supply. And also the geopolitical tensions still remain very high. So overall speaking, I think generative AI has the potential to be transformative in semiconductor supply chain by leveraging the data-driven insights. I talked with our data scientist and also the guy from supply chain and identify some of the use cases that we can utilize generative AI to help with. So for example, like we can use generative AI to help identify the supplier. So we can use the model to analyze some internal and external data to create a supplier catalog. So probably with customer reviews, and also rank the suppliers by like, for example, like a optimal combination of the lead time, the quality of the parts, the delivery capabilities, and the cost. It can help streamline the sourcing decision process. And probably it can also give some recommendations, in terms of which supplier we need to cooperate with. Another use case can be optimizing the supply chain management system. So by analyzing historical data, market trends, and also the demands, it can, the model can generate like more accurate predictions of parts and material requirements. So help the company to keep a very healthy inventory level. And in addition, I think we can utilize generative AI to analyze the product specs and also its historical performance to identify potential defects in parts or materials. And lastly, another use case can be we can use the generative AI to identify some potential risk in the supply chain, such as over-reliance on a single supplier or a region. So for example, when a certain material, let's say nickel, is banned for export, we can ask our AI tools to say, well, please tell us the impact on supply chain and give us a recommendation or a contingency plan to find alternative suppliers. So in this way, we can enhance the supply chain resilience. So with all that said, I think that requires digital transformation on the enterprise level. So we need to ensure the data is available and of high quality. And it also requires like the data integration and the management system in place to collect and clean the data. So they are necessary, they are stored in a good place. So the data from various sources and formats, they are also must be consolidated. So they will be made available for analysis by the generative AI models. And also, I think,
I'm wondering if LAM is advising suppliers on how to be prepared and how to get the data in the right clean and useful and so forth. Do you guys coach some of the suppliers on how to do that?
I think it's going to be a long-term process. So first, we need to identify the use case internally, and then we can prioritize our use case and then develop the tools accordingly. So for now, we are in the process of developing an internal like ChatGPT. So for the internal people, and I think as you just mentioned, in the long term, we can also provide like a continuous learning experience to our suppliers to also involve them and get their feedback and opinions in the loop. So I think that's the plan.
Yeah, it's still early. Well, John, because you're looking at the whole value chain, have you seen success in taking risk out of the supply chain? Are things happening already, or is this a future thought?
I think maybe this is still to come. We have not, particularly Gen AI, we haven't really seen any startup. Perhaps most of these startups are all busy developing foundational models or working out some of the kinks like hallucinations, etc. I think once we have a solid AI core, these other vertical applications will start to get their attention.
Okay, that makes sense. Well, since you're all investors, let's talk about investment. So because I've been supporting our semiconductor business, I took one of our chief strategists in that business to visit some of the Silicon Valley investors in deep tech and semi. And my experience has been that a few years ago, there were very few institutional VCs investing in hardware. And now I am really starting to see more of that happening. I'm wondering if you guys are seeing that as well, and therefore are there more and more institutional investors to syndicate deals with, and do they seem to know what they're doing? John, do you want to take that first?
I think there's definitely a lot of interest in hardware. It comes into waves. There's a huge wave of AI chip even before Gen AI, and with different various level of success. And then I think there's also a lot of effort, like I mentioned earlier, from hardware side. There's just so many different pieces and parts that have to work, from optical interconnect, advanced packaging technologies, all had to come into play to support and sustain this whole Gen AI move. So there are definitely a lot of opportunities, a lot of exciting areas that we look at. The other piece, I think, Robert earlier touched on is also the sort of ESG side of things.
Oh, yeah.
With Gen AI, we know about, training of some of these Gen AI model takes a huge amount of resources, and the model gets bigger and these costs gets higher. How do we, from a chip development, from a chip hardware side, how do we mitigate that issue? And also just from the data center side, for example, we're looking at some of the ESG solutions that goes into what's called the semiconductor subfab. So these are all the, pumps and motors and equipment and that goes into a semiconductor fab that supports the entire operation. If you could make the operation more efficient, for example, we invest in a company that is developing high efficiency motors that give you just a little bit of efficiency boost in a lot of these rotary equipment and tools, and across the entire fab, it actually make a huge difference. We look at water technologies, we look at various different techniques, I guess, software side of techniques to leverage IoT devices to make the semiconductor fabs more efficient and also more intelligent. So in terms of sort of the institutional investors participating, I guess what you mean is really the financial VCs.
Yeah.
So yeah, we always welcome, syndicating with the financial VCs, and I think the feeling is probably mutual.
I would think so.
They, especially in some of these areas that require deep domain technical expertise. On the other hand, with at least the funds that we collaborate with and familiar with, they all seem to know what they're doing and also are developing their own unique perspective and thesis.
Some of those guys came from these industries. They have the right background.
So often they can bring in actually unique perspectives in terms of their investment thesis. That is often beneficial to us as well. So
yeah, that makes sense. Eva, I wanted to ask you, where are you getting your deal flow? Like, do you like to be surprised, or do you go out there looking for specific things, or both?
Yeah, I think we are syndicating with a group of very reputable and also sophisticated institutional investors. So we get our deal flows from our network. So especially the network from our partners. So with several years of investment experience, and also for this sector, I think semiconductor investment is not a generalist sector, right? It requires lots of professionals, with solid background and also industry experience. I think so for now, we're very well plugged into this deep tech investment ecosystem. And we can, collaborate with a group of investors, who can share their insights about the market demands and the trend and the technology trend. So we got lots of the very good quality deal flows from other investors, and also from the peers in the panel.
And do you see anything interesting at any of the accelerators? I know there are a small number of accelerators that are looking at these kinds of spaces in deep tech and so forth. And since you're in a research firm, you must look at real early stage things. Is that right?
So kind of not very early stage. So we kind of want the technology to be approved. So our sweet spot is Series A. Yeah.
Okay, that makes sense.
I think there are accelerators or incubators such as, I think there's a better ecosystem around investing in semi innovation, and I think for example, Silicon Catalyst is
that's what I was thinking of. Yeah,
that is really kind of getting things launched in a sort of pre-seed stage, and then we take a look at their progress, and that's sort of a kind of another kind of a source of deal flow. But one thing I think I had something kind of unique that I've seen at Micron is that some positive surprise is that I get a lot of deal flows actually from internal people.
Oh,
Which
interesting.
is interesting because in a large organization like Micron with so many product lines, and our core cultural kind of a value is
and your guys are out and about too.
Yeah. And whether it's done externally or internally, innovation is one of the key items. So the deal flow from not necessarily from our core business, but sort of adjacent market opportunities. I'm seeing a lot of that internally. So that's just another input on that overall kind of an ecosystem of semi investment. It's wide ranging now.
That's really great. Yeah, I like to hear that. Well, you mentioned a couple of your companies, which sounded pretty exciting. What kinds of innovations are you looking for, or what things are getting you excited right now?
Yeah, I think I've already mentioned portfolio companies, but as we look at Fund 2 and Deep Tech, I mean, we're seeing a lot of kind of activities as well as sort of excitement, still sort of in the edge computing. I think there's still lots of innovations. The growth over the next, decade or 5 years, I think is still going to be like double digit there. So we're seeing a lot of those kinds of companies, non-linear technology there. Electrification is also another big area that we're still seeing lots of deal flow and just a lot of innovations happening there. So we're looking at that and sustainability. We're a hardware company, but we have as many software engineers as hardware. So
of course,
the next generation software development is another key area that we continue to look at. Mobility, of course, next generation mobility. And then we're also seeing some activity that we get excited about, immersive kind of reality technology that's sort of the next stage of like doing holography and things of that nature that really kind of sort of pretty much any areas where will require more extended memory and storage. If you could increase that, building a new market where increased memory and storage capability is required. I mean, that's where we get excited about.
That's really cool. Eva, what gets you excited? And what would you like to see more of?
Well, I think first thing is, in terms of just all these startups, one thing that I notice is that it's just a singular solution for a particular problem, right? Whether it's supply chain, it's chip development, advanced manufacturing, they're looking at, it's rightfully so, they're focusing on one particular, problem. But what I don't see is sort of an entire kind of an end-to-end integration, be able to kind of connect the dots and really optimize that value chain. And, whether Gen AI could kind of really, help in that realm, I'm not sure. But I mean, that's something I really would like to, see if we could find some companies that could really help in that space. For example, like in an automobile, automobile is one of our biggest sector. Optimizing sort of the architecture of the electrical systems in a centralized compute way, because that would really decrease the weight of that automobile, and you could actually do a lot more in an automobile if you could, try to optimize all of those, connections. So I think sort of the overall kind of integration platform of solving all these, smaller problems, but putting it all together in a package, in a platform, I think that's something that I would be really interested.
Okay. Eva, so what's on your wish list, and what do you get excited about right now?
Yeah, so as everyone knows, so Lam Research has a very strong position in memory, and the adoption of AI server will also increase the demand for all types of memory, for HPC or for like high capacity storage devices. And also, according to our data, it's like, so every 1% incremental penetration of AI servers in the data center is expected to add 1 to 1.5 billion of additional WFE investment. And for nowadays, AI servers are accounted for about 6% of the total server volumes.
Oh, wow.
So yeah, that's so this area is of huge interest for Lam Capital. So, and also at the same time, we're very disciplined and selective in terms of investment. I can introduce some of our portfolio companies that are in this space. So one of them is in-memory compute startup. It's called TetraMem. They are using the memristor technology as hardware accelerator for machine learning or artificial intelligence for the edge application. The company was founded by Dr. Glenn, and recently he and his team published an article in Nature talking about this technology. And also, yeah, at the silicon layer of the entire AI tech stack, mentioned by Gerard before. So there will be an incremental demand for advanced packaging to create like more interconnects between the components. So we invested in Silicon Box based in Singapore this year. So it is funded and invested by several seasoned entrepreneurs, and it is building a 2 billion advanced packaging fab in Singapore. So those are some of our portfolios, that are in this area, and we're pretty excited about the future.
Yeah, that reminds me that you're investing in things that are all over the world.
Yeah.
John, is that true for you too? And what gets you excited right now? And we'll wrap up with that.
Yeah. Obviously, we definitely invest all around the world as well. For us, I think a lot of things that the previous 2 panelists talked about are definitely things high on our agenda. Just I guess the general sort of data infrastructure, going from data processing, data transmission, storage, and analytics. We feel like so with Gen AI, there's going to be a lot of opportunities and obviously a lot of enterprise processes and fundamental sort of platform level changes, and that will drive a lot of new innovations in these all the data related areas. So that means both software and hardware side of investments. And for myself personally, as a material guy, I'm kind of interested to see if there are any sort of startup companies that can leverage the Gen AI capabilities and develop new capabilities and tools for chemistry or material development. A few years ago, there's a wave of material informatic companies that are using AI for new material or new chemistry development. The progress has been slow, and I think partially because of the lack of maybe lack of data, and also just the lack of software AI models' ability to extract sort of a human intuitions and insights. But with Gen AI, I think the capability, as I've mentioned, is really able to understand sequence, understand context, and so perhaps this is another opportunity for startups to really develop tools and capabilities that can help with material development. Just like, for example, there are researchers that are retrofitting the GPT tools and use that for protein design, right?
Right.
And there are companies that are doing protein design exactly leveraging the transformer, the diffusion models. I think similar train of thoughts could be applied to chemistry development. And for those of you not familiar with semiconductor industry, we deal with all sorts of crazy chemicals and materials and molecules. And it has both sort of performance and cost impact, but also huge environmental impact. So that's my personal pet peeve of an area that I would like to see startup companies.
Yeah, the Prelude Ventures introduced me to a chemical informatics company called Citrine. I don't know if you've come across them, but they built their own ML models because it's such a specialized field.
Yeah.
Okay, well, I have to thank the panel for all the information and insights and thoughts about what's going on in the semiconductor industry. As I said, we're going to have another session on Gen AI in Palo Alto on September 21st. And let's give our guys a round of applause. Thank you.
Thank you.
Now we have a special treat. It's a special for me anyway, because Sanjay Tripathi from IBM and I worked together for many, many years as we moved through different jobs in the company. And I've known Sanjay when he was in research, when he was working in Internet of Things, when he was doing some things in sustainability, and I was introducing him and the team to some clean tech companies and investors. And now Sanjay is leading our semiconductor product design and production team. Sanjay, would you like to say a couple of words about yourself and what you're doing now?
Sure, absolutely. So, hello everyone. Sanjay Tripathi, currently with IBM Semiconductor, where I lead product and services. Our focus is on helping clients with their process technologies, with their packaging technologies. We have a MES system called SciView that, of course, we go deploy to the leading fabs in the world. And then finally, we have EDA as a service. So helping clients with their data flows, with security, and giving them EDA capabilities on cloud. Internally and prior to IBM, I have been an entrepreneur. So prior to IBM, I helped establish a nanotechnology instrumentation company, sell that. And then before that, very much like Gerard, I was also with McKinsey & Company. On the West Coast, serving clients in semiconductor. I started my career actually at Intel as a process engineer. So the first paper published externally on Copy Exactly, I was the lead author on that. I was also on the core team for the startup of Intel's first 8-inch fab, Intel's first fab in Ireland, and also the Pentium processor. So that is me, Deborah, in 90 seconds or less.
and now you're in Semi, so you've come full circle, right?
Yes,
That's
exactly.
really
Very exciting time to be in the semiconductor
that's
industry.
really great.
For
Well, you
sure.
listened to the panel, I know you did. So do you want to add anything to what they said they're seeing in the industry or their wish list about, what they're getting excited about or hope to see?
Much of what Robert, Eva, and John mentioned, I agree with 100%, and that is a lot of what we are seeing from our clients and that we are adapting internally as well. So supply chain resiliency, we're getting recommendations for next best actions, suppliers, what actions to take to minimize disruptions, materials discovery, absolutely. A lot of that going on as well. Chip design, I think Robert mentioned that early on, synthetic data, something that John mentioned, sustainability that I think has come up over and over again. So absolutely, that is a lot of what we are about as well. A few additional items, I think, from the IBM side, just because IBM, our semiconductor business, our systems business is within a larger IT company. So we are seeing code generation. So Copilot for code. So very much like Gmail or Hotmail, when you're typing your emails, you get a recommendation for how to complete the sentence. So that is, we have a code assistant to help our software engineers write code. And then to modernize code, we're seeing a huge usage of AI and generative AI in that domain. So many of the products in our industry were written in the 90s on C, C++.
Oh, that's true, yeah.
And identifying the architecture, figuring out how to take a monolithic product and break it down into microservices. It's a very difficult problem because products have millions of lines of code. So how do you identify the different components, identify their coupling, their cohesion, which ones should be a natural cluster in and of themselves? Actually, there's a huge amount of AI being deployed in that space. In fact, there is an open source community called Minerva, which has many different libraries on GitHub. That's a place to go to. And then in terms of generating the recommended code, so if once you take a monolithic code, break it down into microservices, experts, of course, right, then make recommendations. The AI can also auto-generate some of the glue code that is required to generate APIs, RESTful APIs, and then have the different modules of code communicate with each other. It's capability that we have developed for many of our legacy transaction mainframe clients in banking, financial services, insurance, airlines, energy utilities, etc., taking that technology and deploying it to help clients who have EDA products, who have other software products in the semiconductor space. So that's another place we're seeing it, Deborah. The two additional areas I'll add is one is maintenance. So you had asked like, hey, are we seeing anything on maintenance? So there, IBM has a product called Maximo. It has been a Gartner Magic Quadrant leading product for as long as anybody can remember. And there, once you train a foundation model on, let's say, right, visual inspection of defects, you can take models trained on boards at Foxconn and then modify and fine tune that and deploy it into Celestic as an example. Not saying that either Foxconn or Celestic are using this, but those are examples. The other piece is reinforcement learning and its applicability in the manufacturing in the fab space itself. So any of us who have been inside a fab or who know how complex it is to maximize OEE in a fab, right? The utilization of equipment, the availability of equipment, the quality of the product that comes out. Much of the knowledge of the policies are in people's heads, in the heads of operations managers, industrial engineers. And with reinforcement learning, you can actually feed these foundation models the data and have them decipher and infer what policies are in given subsets of the fab. And that helps with dispatch policies, that helps with scheduling policies. And so we're seeing pretty strong interest there from our clients who use SciView. So I think those are, from a use case perspective, I think two things to add. The third thing I will close on for the use case perspective, and then I think we can talk about explainability of AI or exactly how to implement and deploy this, Deborah, is sustainability and climate. So you mentioned that I actually was in our sustainability business. I led the acquisition of a company called Envizi, with carbon accounting. And what we have done is, together with Esri, together with NASA, created a large foundation model that is available on Hugging Face, open source, but that can be fine-tuned for different regions, which then helps clients with site selection. Because of course, right, in our world, water availability, scarcity is very important. It's important to identify with the changing weather patterns, right, how the site may look like 5 years, 10 years hence. So having these forecasting models that are basically very large, very robust is something else that we have done and we have made available for our client base.
Yeah, that foundation model was announced in the press, so that's something you know you can go check up on after this. So yeah, I did want to talk about transparency and explainability. John had mentioned ESG, and you know, it's still early days for Gen AI, and the word hallucinations was used a couple of times. So, you know, as a large corporation, and because we do business in the EU and other places where governance is not just important but required, you know, what's our approach to that? How do we look at that at IBM?
Yes, so
I still say our for IBM. I just left like a couple months ago.
Yeah, so for the generative piece, much of this is still a work in progress, but for AI in general, right? I mean, IBM is all about open, trusted, secure, explainable AI, just because, again, of the by virtue of the clients we serve, right? Banks and the fact that they'll originate loans, as an example, right? It needs to be very explainable. But now that we find ourselves in more different domains, like visual inspection of or predictive maintenance, reinforcement learning for fabs and such, and chip design, place and route as an example. Different techniques again, right? So there's saliency maps that people use for images, and the saliency map. The great thing is it can identify which part of the image played a larger weight or function in making a recommendation. There's Lime, there's partial dependence model. So there's different techniques that are used as a method to identify which parts of the data and the neural nets had a disproportionate impact on the recommendations. So I think that is something that we are, I think, strongly focused on, because at this point in time and the stage that we are seeing AI in, it's all about augmenting experts.
Yeah.
Right, it's accelerating work. The automation of work is, I think, by and large in records and transactions, which I think which are generally more routine. So as AI moves higher up the stack, and how you can basically help the expert then make a yeah or nay decision in terms of whether he or she wants to accept the recommendation of the generative model or the AI engine. That is, I think, a lot of our focus.
Yeah.
So these, I think, fundamental mathematical approaches are important. And then with Watson X that IBM released, it's our platform for generative models. It has a AI model element, it has a data element, and it has a governance element. So the data element has a huge amount, Deborah, of identifying and making sure that you as an enterprise have the license to use the data for that purpose. I think some of us may have caught the news just overnight about Zoom having trained many of its AI models without the appropriate permissions, right? Again, just very bad form, right? Does not create a good look. And then it allows clients to use public domain data, their own private data, to create and fine-tune models that are not generally available, to then create and maintain a differentiating advantage. And then the governance, which is a lot about the policies that I mentioned, right? And the governance then links to ML ops, which is, again, right, are you collecting data from the right places? Are you training it in the right way? Are you confident and comfortable with how the model has been trained? You've removed, hate, speech, and other profanity, etc., with the data set, so that's available. And then the recommendations, you as a owner, manager, decision maker, right, have the comfort level in the recommendations that the engine is making. So that's, I think, a lot of the work that IBM is doing in and around Watson X and explainability.
Yeah, that makes sense. And we've been looking at that FX and explainability and transparency for quite some time, actually, as a business. So I need to turn this back over to Axel. He's probably getting nervous, but I just wanted to ask you one real last quick question, which is, in your semiconductor business, are there any startups in the mix who are helping you out?
Oh, yeah, absolutely. So without naming names, but, and I'm not in the corporate venture side, as many of as the three panelists are, but ecosystem is immensely important to us. So we continually make by partner decisions and choices. So it's always, even as a precursor to an acquisition, to partner with a company to understand that it adds value, that the 1 + 1 is 11 exists, that we know how to work together, that we get a better understanding of the product and the technology, is something that we are all about. So yes, in the EDA space, in the manufacturing execution software space, in the process technology space, absolutely. Ecosystem cool. Is the name of the game, because that's how we get the leverage.
Yes, we call it better together. So
better together. Yes. Well said.
Okay, thank you so much, Sanjay. It's a pleasure to see you again. And now I will turn it over to Axel, who has some startups he would like us to meet.
Okay.
Thank you very much.
Thank you so much, Deborah. Thank you so much for the panel. And as our audience can see, Pitch Global is always at the forefront. It's a leading platform for entrepreneurs and CVCs and other investors to meet. And we as Pitch Global have already created for the state of California this year over $100 million in economic impact. Now, even this forum is a collaboration between Pitch Global and the SBDC's San Jose State University arm. And as part of this requirement, we are actually asked to actually collect surveys, and that link was actually in the invite email, but I just put it in again here in chat. I would like everybody to actually open up the link and follow the survey so that we can report back and continue to receive funding for this wonderful and very deep insight and interesting panels. Now, our startup companies are sitting on the edge, and And at this point in time, I'm opening up the floor and I'm going now to gallery mode. I give every startup company right now a 1-minute pitch opportunity to introduce themselves and tell us what they're all about. So who is on first at this point in time? Jim, you are unmuting yourself. You're taking the spot for a startup company.
Okay, can you hear me?
Yes, Jim is,
Okay.
by the way, one of our wonderful longtime advocates of Pitch Global. He has been with us. He is a serial investor, runs a fund in the actually dreaded space of hardware, but as we heard today, it's no longer dreaded. Jim, the floor is yours.
Thank you, Axel. It's always great to be at a Pitch Global event, and it's great to see Deborah and the panel. I'm a board member of Sylvan Source, which is our advanced water and energy company with broad applications in industrial and municipal for water treatment. They also have it, I think we're going to hear a pitch, but they also have energy recovery. They recover waste heat, and suck it from a place that can't be used to someplace that can. More to follow. We think it's a tremendous team and a great company.
Thank you so much. The next one, please. Don't be shy. This is your opportunity to pitch.
I'm happy to go ahead,
Yes.
Laura Bassett. Thank you for having me here. I'm representing Crystal Sonic Incorporated. We're a startup out of Arizona, a technology that can allow the reuse of the advanced material substrates and therefore support, the mega trends towards a cleaner, and smarter society, and by doing so, drastically reducing the cost of our semiconductor devices, be it in the electric vehicles, by up to as much as 50%.
Oh, that's great. Next one, please.
Hi, Axel. This
Hi.
is Jay Gregorius. I'm representing Deeply Human today. So we're an early stage stealth startup. We're focusing on bridging the gap between AI compute and solid state data storage at the component and the platform level. We have a patented semiconductor parallel access architecture that we're happy to present today.
Oh, great. Anybody
Hi.
else?
Yeah,
Yes, please.
I'm Jay Provine from Align Carbon. We manufacture carbon nanotubes for use in integrated circuits, and which can enable to 1,000x improvement in energy lay product of AI processors. And the key component of getting carbon nanotubes out of the lab and into real commercial products is whether there's consistent material to start to build out foundry capability with. And the most important thing is you need to make sure that all your carbon nanotubes are semi-connecting and parallel to each other, which is what we've developed a technology to do that at scale.
Okay, perfect. Thank you so much. So why don't we start today with a fuller pitch for Laura first, and then I will call the others.
Okay, thank you. I'm about to share my screen then. Apologies. Don't be fooled. I'm not in San Francisco. I'm in the middle of nowhere in Northeast England. So I'm praying that my
that's how you sounded like, that you're in the middle of
That's right.
so I'm praying that my children also don't run in. So here goes. Just bear with me 2 seconds. This is all righty. Play from again. Okay, once again, I'm Laura Bathurst. I'm the CFO and co-founder of Crystal Sonic Incorporated. At Crystal Sonic, we are harnessing the power of sound in order to drastically reduce the cost of semiconductor device manufacturing. In doing so, we'll be supporting these global megatrends, which are moving us towards, the greener, cleaner, smarter society. And what these trends are demanding is the faster, smaller, more efficient devices and performance levels for which the traditional silicon devices can no longer deliver. And as such, there's a growing demand for these compound semiconductor materials, such as your gallium nitride, your silicon carbides, gallium arsenides, etc. And as an example, these advanced semiconductors deliver power more efficiently than silicon can. And particularly when it comes to AI, power delivery for AI is one example of where silicon is actually losing its competitive advantage. For AI to reach its potential, it needs supporting infrastructure. Data centers are arguably the most critical piece of that support, and these data centers need the most efficient power devices. So needless to say, the demand for these compound semiconductor materials has risen significantly. It's expected to be around about 2.3 billion in 2027, which is more than double what it is today. But there are a few problems which we intend to address. Yes, demand is great, but actually demand is set to outstrip supply by up to 3 times towards the end of this decade for some of these material sets, which shows a massive opportunity lost, which seems crazy. The demand is crazy given the cost of these materials. If you look at them, it can be 50 times or 100 times, if not more, the cost of silicon. And what's incredibly frustrating is that in the manufacturing of these devices, up to 95% of that material is actually wasted in the backgrinding process. And when you consider that the substrate cost is actually around about 50% of the overall device cost, that is a huge loss and a great opportunity to solve this problem. So we are going to tackle where the waste occurs. And this is in the device in the backgrinding stage. So to go through this, you've got the starting wafer, you've got your chip fabrication, and at the backgrinding stage, before it goes on to dicing and packaging, it's ground down. Around about 95% of that expensive substrate just goes straight in the trash. With our sonic liftoff technology, we enable the wafer to be reused. We use acoustic waves to propagate a crack to separate that device from the original substrate. The device can go on to the dicing and packaging, and then that substrate is then returned, a small kiss polish, and you can grow another device on top of it and reuse it multiple times. In terms of our technological highlights, we've demonstrated the ability to scale this technology. We started off on using 1-inch wafers. We're now at 4-inch and moving towards 6 and beyond. We've demonstrated the ability to regrow on top of the substrates once we've separated it. We've done that multiple times, and there's no degradation to the performance of the device that is grown on a reused substrate versus the original device. We've also been able to demonstrate technology on multiple materials, silicon carbide, gallium nitride, gallium arsenide, etc. So this is a material agnostic process, and so it could be used in multiple manufacturing fabs around the world on multiple material sets. But we're focused on the power electronics market, where the demand, the cost, and availability problem is the most pressing. In terms of where we're at with the market, we've got NDAs in place with the majority of the logos on this page, and we've got major industry players who are actively supporting us in terms of our material set and our substrate size development. Our roadmap is really to build upon the relationships that we've established in order to develop our process to meet the requirements of these strategics, and whilst alongside also designing our tool. So at the end of this kind of seed round, our goal is to demonstrate that we will have a tool which can demonstrate our process on a minimum of 6-inch substrate size. In terms of our revenue model, this is actually a very fast process, unlike backgrinding, which can take hours, if not days. The actual process of cutting the material is less than a second. And so you're not really going to be selling many of these tools because the throughput will be so significant. The value of our technology is in the substrate reuse. So if you've got a $1,000 silicon carbide wafer, you reuse that, once you've effectively brought down the cost of that to $500. And so if you look at that compound semiconductor market, if you reuse each substrate once, then effectively you've created $1.15 billion of value for the overall market. And if you can actually do that multiple times, say 10 times, that value jumps to around about 2.1 billion annually. And given that these markets are growing at rather large compound annual growth rates, that value is only ever going to increase. And in terms of actually how much revenue you can get and how quickly, the markets are pretty consolidated in that you don't really need to have many customers in one particular market in order to have a good chunk of that market. So here's the team. I'm very humbled to work with such an excellent team, and the inventors of the technology remain with us and remain fully engaged. We're growing. And in addition to the technology expertise, we have a lot of business development, strategy, and startup experience, and also successful exits. So we've raised 2 million to date, which has been primarily government grants. We're looking to raise 5 million. And we're seeking this investor capital to accelerate our go-to-market. We need to build a team and arm them with the relevant tools and the relevant equipment to develop on our roadmap. And in doing so, we'll demonstrate we're able to drastically reduce device manufacturing costs, but also to highlight the competitive advantage that a major player could achieve with our technology. With that, I will close and ask if you have any questions.
Thank you so much, Lara. Very great presentation. And anybody from our audience that has any questions?
What is the foundational IP behind this, Lara?
So this was developed at Arizona State University out of Professor Mariana Bertoni's lab. So we have the exclusive license from Arizona State University. Mariana is actually my co-founder. And then we also have Crystal Sonic has tool patents and some additional patents that are underway right now.
Thank you.
By the way, can you stop your share?
Yep, sure.
Our next full presenter, Jim, are you ready to give us a full pitch of the company?
Okay, yes. Can you still hear me?
Yes, we can hear you.
All right. Let's see. New computer here, but you'd think this would be a little easier. Okay. Let's see.
Would you like to try a little bit offline?
Yeah, you go to the next one. The new computer is giving me. Sorry for this, but I'll figure it out.
Ja Gregorius, are you ready to pitch?
Sure.
Okay, Ja,
Sure.
the floor is yours. Deeply.
Okay. Are you able to see this?
Yes, we do.
Presentation?
Yes.
Excellent. Okay, so good morning, everyone. Thanks for having me. I'm Jay Gregorius. I'm the CEO of Deeply Human. As mentioned earlier, we're an early stage stealth startup, and we're developing a custom ASIC that bridges both the AI compute and the solid state data storage domain. So just a quick overview of the team. Combined, we have over 135 years of experience in semiconductor chip design, storage, platforms, secure computing, with roles in some of the major industry companies such as Apple, Intel, Microsoft, Meta, Micron, and Cisco. So why did we form Deeply Human, and why now? Right? So the recent commercialization of generative AI and its use cases, such as simulating real conditions and predicting future scenarios, is going to boost the amount of synthetic industry data from 1% in 2021 to over 60% in 2025. Additionally, by 2025, more than 55% of all the data analysis in deep neural networks is going to occur at the edge where the data is captured. That's up from 10% in 2021. So as Gerard touched on this earlier, Gen AI is going to require a rethinking of the current infrastructure, and we feel Deeply Human is positioned for this transformation. So some of the problems that we see today is that the compute for AI and the storage systems are separate. That's due to the single-purpose semiconductor chips. Now, as the AI models grow, the processing and the data movement inefficiencies in the overall architecture are going to become more obvious. Also, GPUs in general weren't specifically designed for AI tasks, just like CPUs were a little bit of overkill in the early days of GUI, right? But AI processing at the edge limits scalability as processing can't keep up with the amount of data collected. And then finally, systems without support for hardware root of trust inhibits data sharing. I think John mentioned this a little bit earlier. So in this example, it shows a typical on-prem setup where the AI ML processing and the data storage are distributed. So as the AI models increase, it requires more and frequent data transfer between the memory and the storage. And eventually the SAN switch becomes the bottleneck. So having separate servers also increases the risk of a security breach. So how do we find solutions for these problems? So our solution merges both the AI ML compute and the storage systems into one device or platform. So that enables more efficient AI ML workload processing, storage scalability, and hardware-based root of trust through our parallel architecture consolidated ASIC. So going back to the earlier example, one data center platform that's built around our semiconductor ASIC will synergize both the compute and the data, eliminating the SAN switch bottleneck and allowing both AI ML compute and storage to scale. Our modular design is also enabling compute and storage to scale at the IoT and edge devices, thereby reducing the movement through the cloud. This saves bandwidth and electricity when the computation is done locally. So moving on to our product offerings. We're starting with the Neuron storage chipset. This can be licensed to edge and IoT suppliers. And then building on the Neuron storage chipset, we can also productize AI accelerators, which would be plugged into existing hardware infrastructures and add additional AI compute capability, as well as solid-state storage. Scaling further up to the Synapsing storage server, the architecture can be designed into purpose-built AI storage servers and racks. So from the business model standpoint, the architecture can bring value to multiple industries with revenue streams from chipset licensing, accelerator cards, and data center platform and racks, as well as the related software as a service AI tools. Target customers include the cloud providers and hyperscalers that are building out their own AI infrastructure, as well as those renting AI VMs to small and medium businesses. Edge suppliers can also benefit as our design is modular. So moving on to the competition, it shows a list of the, some of the top AI semiconductor chips, companies, servers, and storage. So they range from the Titans all the way to traditional server companies and storage system providers. All of these are candidates for investment, partnerships, and possible acquisitions. So our goal is to reach out to them individually and collectively so they can see the advantage of the Deeply Human architecture. Finally, funding goals. To date, we've raised about $120,000 through friends and family investments, and we're bootstrapping, but we're looking for a seed round goal of $5 million. We want to grow the product and design teams, purchase additional IPs and design tools, eventually build the prototypes, and then build on the additional patent portfolio that we've already started. That's the end of the slide deck. I wanted to thank you for the time and ask if there's any questions.
I have a question. I'm dying to know why this company is called Deeply Human.
That's a very good point. So we were talking about AI in the term artificial intelligence, and we wanted to make a system that's actually less artificial and more intelligent. And we believe that the applications for our chip can span everything from, industrial improvements to medical innovation. So we think once it's deployed, it can touch all the lives in multiple humans.
Okay, thanks.
Do I understand this correctly? While you're talking about a ship, you have an ARM business model, right? You don't intend to produce a ship.
That's correct. We'll design it, and it's going to be outsourced.
Okay. Got it.
Mhm.
Do we have any questions? Then stop the share at this point in time. If I just give a little bit background on the semiconductor company where I was sitting on the board of directors, where we burned through about $140 million. My personal opinion on that company was that they actually missed the opportunity to bring a product into the market. I, in my career, have several times with design tool technology and so on, always had the tremendous uplift to convince others to use my product versus me using my product myself. So if you find the pathway to actually come up with a product usage on your own, you may actually get a much higher traction from all your partners versus trying to convince them. And we were in that game with Intel, Apple, IBM, you name it. And please reach out to me. I can talk about it in more detail under excel@pitchglobal.com.
That's a very good point. I've had the same experience.
Thank you, Deb.
Great, thank you.
So, Jim, did you overcome your technology hurdle?
I believe so. Let's see here.
Yes.
Okay. Thank you. All right. So I'm a board member of Sylvan Source, which is our advanced water and energy company for industrial and municipal applications. We have 3 product families. First is the core water treatment system, which up to 50% lower CapEx and OpEx, and footprint is 50 to 75% smaller because of the proprietary heat transfer technology that's used. The second is something called Terra Thermal Energy Recovery Ray. This is the heat transfer technology that takes waste heat. There's more heat wasted in the US than is used. Takes waste heat from one place and sucks it over to another place where it can be used. And integrated heat transfer devices do the same thing for waste heat, but they're built into equipment. So that's, and you can see we have plenty of patents and IP. I'm just going to talk about the water treatment system due to time today. I think we probably all know that, the problems with water scarcity globally, many applications in many industries, power generation, oil and gas, semiconductor. So it's a very important need. The market size we estimate, of course, this is the overall market size, but the addressable market that we can address is, a few years ago, we estimated at 20 billion per year. These are some of the participants. This is the system, which we call the core, and it is up to 4 times more energy efficient. One of the major competitors is reverse osmosis, which is great. It's the state of the art today, but an RO system of several $1 million has membranes, which cost $1 million or more, and they can be replaced as often as every year. We have no membranes. And here's the technology. It's a thermal transfer mechanism, which is 3 to 4 times better than conventional. There's the actual data proven in the field, which leads to far less metals in surface area, in lower CapEx and OpEx, and there's some numbers on that. The team, Laura Dimmons and Gary Lum, worked together at Hewlett-Packard back when Hewlett and Packard were there as a great company. They took their laptop computer division from 400 million in losses to 2 billion in revenue and profits in 2 years. So it's a pretty good team. There's others, of course. Customer traction post-COVID, the company is in the last year, there's been really a lot of progress. We had one customer that believed that this story was too good to be true. They said that's impossible. So we got a senior physicist from Fermilab, the particle physics lab in Illinois, to look at our technology under NDA. And he did a press release saying there's plenty of room within the laws of physics. This can be scaled. So as a result, the company hired a PhD in chemistry who's in sales, who had a lot of credibility, and he's gotten a lot of interest with a very large chemical company. This is one of the 5 largest in the world, and 3 engagement options. That means a minimum of 3 systems. Each system is 10 million in revenue. So there's an oil and gas services company with as it says here, potential collaboration structure. and also revenue. There's 2 semiconductor companies. They're again talking about multiple systems, each one being 10 million each. So this is the projection, the projected income statement for the water treatment for the core only. And you can see revenue. This is 4 years after funding, 280 million. This is a profitable company, unlike the software companies where there's a lot of money spent on sales and marketing. This, they believe in profit, and you can see it's about 15-20% net profit after tax. And finally, the company will get to 15 million's been raised, 12 million gets it to cash flow break even. They're raising 3 million round right now. And I think I'll stop there to take questions. Make sure I don't go over my time.
Yeah, Jim, I have one question because I am a little bit familiar also with that space. You're talking about wastewater that is used in production to basically cleaned up again. Why would you not also apply the system technology to actually, because we have plenty of supply of water, it's just the wrong type, right? Why not do desalination with it on a massive scale?
Well, absolutely. And we said in there, industrial municipal, desalination is going to be municipal, and the cities move more slowly than industry. So absolutely, that's our plan is first industries and then municipal desalination. Absolutely. So the answer.
How do you compare to the regular water supply price-wise out of your system? Because that will be always a question, right? Can you compete with the current freshwater supply when you would desalinate?
Yeah, I think what you're asking is how do we compete with the way they desalinate today, which is typically reverse osmosis. And, we'll have to do detailed benchmarks, but we think there'll be, less CapEx and less OpEx. So both. So okay. I think it should be, quite compelling. I think go ahead. I'm sorry.
As soon as they come to the same level, freshwater and desalinated water, you are competing in an open market, right? So, and water supply, as you say, is always on short supply for fresh water, but this could be the solution around the world.
Absolutely. And there's interest around the world. I mean, there's, in India and the Middle East and many areas where, especially where there's water scarcity. And there's a lot of companies, I think most of the oil super majors are very interested in deploying after they see a first deployment. And you can see with those, let's see here, I'll go back to these people here want to deploy first. So I think, they're definitely a very large market. Absolutely. So
hey, Jim, the state of California has publicly announced that we're going to start using in the larger municipalities, not in Burlingame where I live, but like in LA and Sacramento and so forth. They're going to start treating wastewater and combining that with the freshwater systems. Have you seen that? Have you taken a look at that?
Yes. Typically, again, that's municipal, and typically they want to see broad deployments that they're really risk averse, and it may be because their financial structure, there's a lot of debt, but
well, it's also very public, so they get nervous.
yeah, but absolutely there's interest there, and like in San Diego, it's the toilet to taps, and this is thermal.
yeah, the headline said, please don't call it toilet to taps.
That's right. But this is better than drinking water quality. This is like 1 part per million, and drinking water quality is about 300. So
yeah, that's right.
So yes, absolutely. Okay. Yes.
Thanks.
Thank you so much, Jim. If you can stop the share.
Okay.
Come to our last presenter, George Guo. Are you ready to pitch to us today your full story?
Yes. Okay. Let me share a screen. And okay.
I saw that you started doing your homework. That's good.
Okay. Yes. Sorry, that's the last page, but it's okay. So I'm the co-founder and the CEO of the company. We've been more than 18 years old. If there's anything related to AI, we might be UI, ultimate intelligence. The reason is this. Think about the semiconductors, solar panels, batteries, they're all films on some kind of substrate. So if we can get the deposition part or edge part to the, the nature's limit, then that's the ultimate way you can do it. No matter what kind of AI come up, this is nature's limit. So I think that's related. So that's what we've been doing for the last, I would say 35 years, but this company been doing that 18 years. So the way we do it is, first we worked at the leading institutions, including Applied Materials, and we developed many #1 market share product. Then we learned many skills from a broad field. Then we say, what is the ultimate solution, for each problem? So we look at how to achieve this on every aspect, and eventually we get all of that, the best we can do. We call nature's limit. So we have a lot of these designs, everything. So we have IPs covering a wide area from semiconductor, clean tech to fusion. So I'm going to pick the semiconductor as our first use case. If you look at semiconductor, it is a cluster tool normally. It has CVD, PECVD, edge, EUV, multi-beam. I worked on all of them. So we have a lot of IP on this. So typically these are many times better. And mostly we see this ultimate solution. The one we have at our core is this best, highest density plasma in the world. You know that by the operating pressure you have. With this, we can analyze everything, no neutrals, we can fill gaps. So since the semiconductor, here are some results. So this is like 10 nanometer gap, re-entrant. Basically, it's almost closed up. We get the wafer. We can get 100% with ions. I've never seen results like this. In fact, we think we probably the only one can explain how we can get this. So this is for small feature filling. Also for very high aspect ratio, we can get like a 70–80% gap fill for 10:1. This is the best you can do. Actually, this is the best you can do with the current hardware we have, but we can improve that another factor 10 if needed. So we have every aspect is kind of studied. This is part of our Lam research here. We can tilt the beam so that we can etch them. We can deposit, we can etch, we can tilt. So in a sense, we can drive the materials down to the bottom. That I don't think nobody can do. So anyway, this is an example for semiconductor, but we have a lot of solutions for clean tech. For example, we can use 100% of materials, sputtering, evaporation, PECVD. That is 100% wafer material to the wafer, which is unheard of. If you look at what they typically achieve, it's less than 20%. For semi, sometimes less than 5%. But we just have all the things. As an equipment vendor, equipment is very important for performance and cost. So this is on the right is what we sold. The one below is what we currently have. For example, we have many platforms to reach like anywhere from 4 to 100 times higher throughput. All of them use 100% materials, no plasma damage. So it's a kind of ultimate solution for deposition. We also have a solution for etch also. So to see, just to summarize what we got, is that we have #1, we think we have the best technology, the ultimate, and we developed many top market share products in the past. Right now we have many solutions, have many IPs. Our IPs like we have a lot of issue patent, and also we have a lot of provisional patent, which we recycle. Basically, all our solutions are those things. When we don't have customers or don't have a need, we recycle them. So in the sense that we covered many of those future technology. So, when a customer comes to us, like a equipment company, we can have a whole, design for that with the data so that it can become a #1 in the field. So that's what we're looking for customers in the semiconductor for the clean tech so that we can really make them #1 in their field. So happy to take questions.
Thank you so much. And interesting presentation. Do any of our guests have any questions? Otherwise, I would like to make a point to some of the previous questions. And actually, I'm probably very lackadaisical about those things myself, but Deborah, coming from the corporate world, highlighted with me in the chat, many of you are using big company logos as prospects or customers. The reality is that IBM and most of the others have extreme strict guidelines and legal circumstances on the usage of their logos. And Deborah definitely recommends against using the logos in presentations, because one day it could bite you at the wrong time, in the wrong position, and we want to avoid that. Deborah, is it okay if they just mention the company names instead of the logos?
Well, I think that what Jim did was perfect, because Jim said a large manufacturing firm and chemical company that does this, and we're talking to them now, and this is where we are in the discussions. Jim's a real professional, not that the other people are not, but I really like the way he did this, and I think we can all learn from that.
Thank you so much for this comment. And yeah, if we don't have any other questions, let me do the housekeeping one more time. I appreciate if you fill out the survey, because that's what's required from us. I want to thank you very much to the participants for the interesting panel and the keynote again. It was wonderful to hear all your content, and I hope I see most of you on the 21st on our live AI event, and also our CVC partners on the 22nd, where Pitch Global has the third CVC conference since its inception of focusing on CVCs and the ecosystem. And it will be a great event all day in downtown San Francisco at the new permitting building. And Casey and I are very much looking forward to having all of you at this point in time. And Deborah, thank you so much for your wonderful moderation of the panels and everything. Your wealth of information is absolutely great, and we are looking forward to doing many of those sessions with you.
It's a lot of fun, and I want to thank everyone who participated, especially the panel and Sanjay and all the great companies that presented. And thank you, Axel and Casey, who's not on here. Oh, I guess Casey is in the audience. Thank you for helping me set this up.
Okay, thank you so much again. Okay, bye-bye.
Bye, thank
you.
Bye.
Bye. Thank you.